All right, welcome. Today we have with us Kevin Shoemaker from TEC. He's one of our engineers over here. He's going to walk us through the Carrier Toshiba VRF line, application and product angle. So I'm going to turn it over to Kevin, and I'm going to be quiet and do nothing today. Thank you, Kevin.
Thank you, Ryan. Ladies and gentlemen, thanks this morning for joining me. I appreciate it. Know it's hot out there today, and you guys are probably busy as heck, so thanks for carving out a portion of your morning for a little VRF training here. And just to, I guess, go over things real quick before I start clicking through slides. Guys, really, this is what the title says, application and product training. We're not going to get too far, into the weeds on VRF. I know it's pretty easy to do that nowadays with how it's being applied. Anything specific, I'm more than willing to respond to it after the presentation here, because then we can really get into the specifics. I really don't want to go off into any tangents, but I am always available to answer any questions. But for the ones that are a little bit more specific, I'd just like to save till after the prezo. But I'll start motoring through the slides here. All right, we all know what VRF is. It's been around for quite some time here. We know it's one of the staples overseas. Really, not a lot of large chiller plants or boiler plants overseas. They start with VRF over there, and it's it's trickled its way over here to the States, and it's been fairly effective here. We should all know the benefits: energy efficient, high reliability. Individual comfort zones and control. They are quiet, relatively speaking, to their counterparts, whether that be a large condensing unit, air-cooled chiller. They are quiet. Multiple indoor unit options. We all know the different fan coil types. Pretty much any fan coil type that we're used to on the hydronic side of things, we can do the exact same with VRF. Low maintenance and piping flexibility. Yes, these systems can handle a lot of pipe, but we do need to be careful. It's dependent on our application, right? What type of building we're trying to install the systems in. But we can get into that later on when it comes to more application-specific stuff. The VRF technology overview. What is VRF? Variable refrigerant flow, scalable, very easy to zone, achieving higher levels of comfort and control, saving energy and operational costs. It's adaptable to pretty much any application that you're looking at, especially from a comfort cooling standpoint. When it comes to ventilation systems, it's a little different animal if you're trying to apply VRF. There is an application for it, but in our market, we might steer you towards a different solution when it comes to the ventilation loads that we have to tackle in some of our projects. So two primary systems when it comes to VRF: heat pump and heat recovery. We're all familiar with the heat pump technology, and that, hey, the system's going to be either in cooling or it's going to be in heating. Can't be in both. If you want both, we go to heat recovery, and we'll get deeper into that as we go through the slides here. So here's our heat pump, typical layout, right? We have our outdoor unit cluster, whether it be roof mounted, grade mounted, and then we have all of our indoor units. The blue shading, obviously, representing the system being in cooling mode. Most importantly, you see all the units are in cooling mode, right? So even if this guy right in the middle sitting in this office wants heat, he's not going to get it because we got a heat pump system here. I mean, there's ways that you can design heat pump systems. So we could essentially give this interior office heating, but once again, application specific, we can get into that once we dive deeper into your application. Heat recovery. As you can see here, we got different shadings, right? So we got our blue, representative of cooling, and our red representative of heating. Now this is more if your customer is looking for true, and my analogy is looking for true 4-pipe control, right? Where you have both chilled water and hot water loops running around your building. You can essentially give your occupant cooling or heating 365, 427 or 424, whatever you want to call it. We got it. Heat recovery is the best fit. Our overview here, and you guys have probably seen these system types before. So we have our large branch selector, or what we call here at Carrier our flow selector model, where you have one large flow selector distributing refrigerant to all of your indoor units or VRF fan coils. Now, a different style heat recovery is our 3-pipe heat recovery system. This diagram right here is showing single port flow selectors feeding each respective fan coil. Another diagram of a 3-pipe heat recovery system is where we have larger flow selectors. In this case, this would be representative of a 4-port flow selector. 1, 2, 3, 4. Also, larger flow selectors are available with the TOSHIBA-Carrier, in particularly would be the 4 and the 6. And then onto our typical heat pump diagram, where you have essentially one large main running throughout your building, typically in the corridors, and then we're branching off into our spaces to each individual fan coil. Heat pump systems, the technology overview. So here's just a couple pics of our outdoor units, our Carrier or Bryant branded outdoor unit, and then our TOSHIBA-Carrier outdoor unit. Today, guys, we're going to be focusing more on the TOSHIBA-Carrier line. That's just our go-to for our market needs here in Chicago, and particularly the climate and low ambient heating requirements. Obviously, they control compressor speed, maintains operational mode, whether it be in cooling or heating. Indoor units, see, this is the most common nowadays. This is what I see the most often are the 4-way cassettes. Obviously, we know what those do, transfer heat and cooling to space, and then our controls. It's another diagram here, outdoor unit. Heat pump, obviously, right? We're not seeing any flow selector boxes. That's the #1 takeaway if you guys are ever looking at plans and you don't see any intermediate boxes, I guess, right? In between the outdoor unit and the indoor units, that's telltale that it's going to be a heat pump system. So good applications for heat pump systems, gyms, lobbies, churches. So let's think about it, large open spaces, single common zones, right? So you're going to either have a request for cooling or a request for heating in these large spaces, which is a good fit for heat pump. Because there's no conflicting demands, right, from what the occupant needs, whether it be cooling or heating. Heat recovery, and this is where we get into our 3-pipe layout. So it's no longer just a liquid and a suction line, right? So we got a liquid, a suction, and a hot gas line. That's where the whole 3-pipe terminology comes from. Our outdoor unit here, as mentioned previously, flow selector boxes, indoor units, and our wall controller. Applications for heat recovery systems, classrooms, offices, assisted living, right? This is where we have typically a bunch of smaller zones, different exposures. So you might very well have a room on the east side of the building, huge solar gain, they're going to want cooling in the morning, right? Well, you got another room on the flip side, west side of the building, that could very well be calling for heat first thing in the morning. Good application there for heat recovery. Not so good application for heat pump, especially if it's not laid out accordingly from a system standpoint with interior and exterior zones. Product overview here on our 3-pipe. Outdoor unit. This is a snapshot of our mini VRF system. This really doesn't apply for 3-pipe VRF. This is heat pump only. So liquid suction. And then here's just sort of a swoop line here of just about all of our indoor unit types. As you can see, we got just about everyone covered. High static, vertical, which is real similar to a furnace type application, same size, height, width, depth. Good for closets, cassettes, under ceiling. So these are exposed, hanging right under a finished ceiling. Compact cassettes, concealed ducted horizontal, high wall. We all know these, recessed in a wall, and these obviously exposed down on the floor. So our breakdown here, guys, on our outdoor units. 21 unit sizes, and you can see we go from 6 ton all the way up to 38 tons. 208, 233 phase, 463 phase. We also have some single phase models, which I'll get into. 50 to 130% connected capacity. Really, I don't like to go over 130%. I've never designed them over 130%. If we do get into this 150% range, where it just has to go that route for whatever reason, we can look into that. So our single modules, 6, 8, not sure why they got 9 here, but this should be 10 tons, obviously, right? 120,000 BTU, 12 tons, and our largest module being 14 tons. So really the way this works, folks, is these dual module and triple module systems are a cluster of our 6, 8, 10, 12, or 14 ton. Now, what Toshiba's done is they've done the math, they've done the energy calcs on these systems, and they've paired the appropriate modules together to give the most efficient system at these capacities. 16, 16S, which is our reduced footprint 16-ton system. We'll get more into that. 18, 20, 22, 24, 26, 28, and then we could see all the way up to 38 tons. Our mini VRF, 3, 4, 5 ton, very similar to everyone else's mini VRF. One thing that you do need to note here is our max indoor units, so IDU standing for indoor units, that you can hang off of this mini VRF condensing unit, 6, 8, and 9. So we are capped there.
Hey, Kevin.
Well, yeah.
We did have a question from Sean asking if you can explain what connected capacity means.
So connected capacity, Sean, is where you have a nominal capacity on your outdoor unit, right, or your VRF condensing unit. Now, your connected capacity is going to be your nominal capacity indoor units or VRF fan coils, okay? You're going to have that capacity, and you're going to compare that versus what you have on the nominal outdoor side. So your percentage, so let's say you got a 5-ton unit and you're hanging more than 5 tons off of it, your connected capacity is going to be over 100% because you've exceeded that 5-ton nominal outdoor unit capacity, which is fine, but it's all application specific. So we got to be careful. We got to know what we're serving, most importantly. We already went over this slide essentially, guys. It's pretty much the same as the heat pump slide, just that this guy has heat recovery up at the top. Same thing, we already went through this. So this is where I mentioned where Toshiba-Carrier is unique in that we do have single phase heat recovery systems at 6 ton and 12 tons. So you can see we have a single module, 6 tons that can be single phase. And then also 12 ton, which is obviously 2 6-ton modules ganged together that can be single phase. So, we see these, larger high-end homes, 5,000, 6,000, even 10,000 square foot homes where, previously they were served by a bunch of, residential split systems. And now they want to go VRF due to the energy efficiency, and yet they don't want to spend the money to bring 3-phase power into their property. We do have a good fit here, guys. This does come up. It's a good fit. Just any applications come up, reach out to me. I'm more than willing to help you guys out with this. So this is a good diagram here of our 3-pipe, and that we're showing liquid suction and hot gas lines going to our flow selector boxes. This is actually a good image of our single port boxes, showing this single port actually showing feeding 2 4-way cassettes. So figure you got a large conference room or just a large multi-use space. You can feed 2 fan coils off of 1 flow selector. Our indoor unit lineup. Here's our 4-ways, high wall, ducted. This would be our slim, high static, medium static. So we cover pretty much anything that you would need from a ducted standpoint. We got you covered. This would be our under ceiling model. And you guys can see my cursor. Ryan, you can see my cursor?
Are you moving it right now?
Yeah, can you see it?
Yeah, okay, I see it.
Okay,
my
perfect. I just want to make sure you guys see that. Great. So 11 indoor unit types. Going all the way up to 8 tons there. They're all single phase, no option to do 3-phase on that. Integral condensate pumps, just depending on the model. All of our cassettes have integral condensate pumps, slim and medium static, integral condensate pumps, high static, remote mounted, field installed, high wall, remote mounted, field installed. So there is some things that you need to be aware of on the condensate side, depending on what type we're going with. These come up, they're a rarity, but Carrier does have a fan coil, or it is actually a rooftop unit that will fit on our legacy footprints. So if for whatever reason you have an owner that wants to go VRF, they have, we can't do the traditional route where we're mounting, VRF fan coils indoors, and they have some existing Carrier rooftop units. We do have an option for you there. We really have to look at the application and what the needs are. Just because of our heating demands here in Chicago, we got to remember that this is a heat pump, right? So we just need to be careful there. Nice side-by-side comparison here, the heat pump system versus a heat recovery system. Once again, telltale that it's a heat recovery. We have these flow selector boxes in between the outdoor unit and the fan coils. This further shows how our 40 QQ unit, which is the rooftop unit, and what footprints it will fit. Really don't need to go through the advantages there, guys. I really don't think we're going to be seeing this much, but it is available. Try to keep that in the back of your mind. So starting with our flow selectors, single port and long pipe flow selectors. Oops, sorry about that, guys. And this here shows how many indoor units we can actually connect to our single port boxes. You see our BTU ranges here, 5, 8, and 8. Honestly, guys, we'll never see this. I've connected maybe 2, 3 max to a single port box. It just doesn't lay out right when you're having multiple indoor units hanging off of this. I've never really seen it. It doesn't make sense really, but it is available for that oddball application. Max distance 49, max distance you can see 164, obviously for the long pipe flow selectors. Next slide. TOSHIBA-Carrier, we go up to 4 and 6 with being our max flow selector option. Now, as you might be asking yourself, I mean, you've seen branch controllers with probably up to 16, 18 ports. You know, Toshiba's mindset with this is that we more want redundancy from a flow selector standpoint. So if you can imagine, you know, you got a whole wing of a building that's being served by a 16 or 18 port box. If there's any issues with that box, you're going to lose that whole wing. While TOSHIBA-Carrier's mindset is break it up. If you do have any issues with the flow selector, you're not going to lose that entire wing. So that's the whole mindset there, guys. This goes more into the technology here on the outdoor unit side of things. Each of our modules, right, that make up the cluster of outdoor units will have twin rotary full variable speed compressors, okay? So at all times, those compressors are going to be varying their speed. No lead lag, nothing like that. They're both variable speed. They share time, that being run time.
Kevin, we did have another question come in.
Sure, shoot.
From Chun, what are the differences between single pipe flow selector and long pipe flow selector?
Sure, I can go back to that. So really the differences here, Sean, if you just look in this far right column, so that 49-foot mark and this 164-foot mark, that's how much pipe we can hang off of that flow selector, okay? So if you can envision 164 feet of liquid and suction line coming off of that flow selector to the respective indoor unit or fan coil. Sorry guys, throwing a lot of terms here. We use IDU, VRF fan coil, you name it. Back to where we were here. Okay. Just a simple diagram here of how our compressors are loaded, right? High noon, we're going to be at full load, but then you're going to see as we taper down, right, we're going to start sharing that load, and that load is going to be shared through our compressors and where we're most efficient at. You can see this diagram down here on the bottom. 30 to 80% is our sweet spot, and that's where our factory controls are going to try to keep our compressors running at, because that's where we're most efficient at. Oil management. This is important to TOSHIBA-Carrier. This is something that we always try to educate our customers on, and that TOSHIBA-Carrier is huge on oil management. We always want to make sure that our compressors are seeing proper oil levels, okay? See, it is a complex system. Probably really don't need to get into the weeds too much on this, but essentially there is an oil separator here for if there is any issues with oil levels in our compressors, the system will appropriately distribute the oil. It's a little depiction there of what happens. Opening up solenoid valves, whatnot. You can see right here, big bold black letters. If compressor oil is insufficient, oil will be supplied from the oil separator. The control equalizes the amount of oil between two compressors. Temperature sensors or time control may determine whether the compressors have the right amount of refrigerant or not. The oil balance circuit can resolve imbalance of two compressors. Let's click through here. Something that Toshiba-Carrier has is we have a separate line for when we're connecting outdoor unit modules, which is our oil balance line. So not only is the oil shared within the outdoor unit itself, but when we have multiple module systems, there is an oil balance line that will be connected to, this showing a dual module, and then also if we ever to have a triple module, we'd see another module over here where that oil balance line would be connected to that third module. So we're sharing the oil throughout that entire system. Piping. So if you guys bring an application to us, there is going to be some questions, right? We need to determine what you're actually looking at, what the application needs, and building type. Where we're going to put the condensing units. Are we going to put them on the roof? Are we going to put them on grade? Do we have a large floor plan that we're trying to stretch pipe across? There's going to be a lot of questions because there are limitations to VRF. Is it a little bit more flexible than a traditional split system? Sure, but there are some caveats and we need to be careful. So first and foremost, 164 feet. So from our very first branch, and this branch is typically, right below the cluster of condensing units, right below the deck is going to be our first branch. So that's going to be our target mark. And then we're going to know that we'll be able to do 164 feet, obviously showing the elevation here, from that first branch or first takeoff from your main, leaving your outdoor units, all the way down to your furthest most indoor unit or fan coil. And you guys can leave that up to me when I'm designing the system for you. If we do run into any issues, I'll be able to tell you, exactly why we are and why we might need to go with two systems versus one. Furthest equivalent, so that's total piping length, right? 650 feet. So heat recovery with our condensing units grade mounted, you're going to see 100 feet. So what does this tell you? Ideally, we want our outdoor units to be above our indoor units if we do have some pretty large vertical constraints to tackle or to overcome.
Hey, Kevin, I don't remember if you had this in your slides or not, but the question is, must the VRF unit be outdoor or can it be mounted indoors in a mechanical room?
We can do indoor. So really what happens there, they're going to be in a mechanical space that has a large exterior wall, right? They'll never be mounted indoors. I've never seen it that way. So they'll be on an exterior walled room. Essentially, that whole exterior wall will be louvered for the incoming condenser air, and then you'll have a louver right above that intake louver, which will be ducted to the outlet of those condensing units. So yes, to answer your question, we can do indoor unit installations. Could get into the weeds a lot more on that, but we can do it. So our refrigerant control, exclusive to Toshiba-Carrier. So each fan coil is going to have a Pmv valve or pulse motor valve. And you can see off means off, right? Quotations. There's a purpose why we have that. We are 100% closed on our Pmv, okay? So if you guys can envision this, you have a heat recovery system and you have some interior zones that really are not calling for heating and or cooling. So we don't want any refrigerant traveling through that indoor coil, because we could be, if that were the case, we could be overheating or overcooling a space. So that's where our 100% closed PMV can be extremely advantageous, because there are some competitors that don't have that. I'm not going to name any names, but just remember, TOSHIBA-Carrier is 100% closed. So you don't run into that nuisance call or anything like that. So our inverter control, specifically as it applies to our compressors, you can see our increments here of control, which are extremely tight. Thus, our ability to match system loads is high. As for the controls, our typical wall controller here, programmable, can adjust fan speeds, can do a lot with these wall controllers. Color touch screen. Now this is more of a front-end control for our VRF systems. So you can see everything here, labeling all of your indoor units, being able to dive into each fan coil within that system. You can also do scheduling through this. A lot of information is available through this color touch screen. We like to recommend these because this would be our central controller for, let's say, if you didn't have a building automation system within your building, you would definitely want a central system control so you can see everything that's going on with your VRF systems all in one location. These also have remote viewing app availability. So really, if you got an IP connection, you can do remote control with having this color touch screen. To the right here, if you do have a backnet system or an automation system, we do have a BMS interface. Some more particulars on our wall controller. Fan speeds, clock setting, scheduling. Pretty much everything that you would need there. Also a more simple remote. If really you just got a user that's just looking to, mess with the set point, this is all they would really need. You got to remember, if you have a central system controller, you could make all of those changes at the central system. Also some button sensors if you're not looking to give any control at all to the user. Really, you don't even need these because each fan coil is going to have a return air sensor, obviously, and we can set the system up to control per return air temp at each fan coil. Also a wireless remote control kit. Don't see these much. Obviously easy to lose, whatnot. You're relying on wireless connectivity, so you got a battery. We do see these from time to time, but mostly it's a wired controller. But wireless is available if you need it. So an ERV controller gives you the ability to control an ERV unit from a Toshiba-Carrier control network. So really, guys, this is the controller that we can integrate into our VRF control system, okay, that could turn on an ERV. It could also enable a DOAS unit. And this could all be run through our control system so it can be scheduled. So just a nice add-on there if you don't have a building automation system and you still want to be able to utilize our VRF controls, we do have something to where we could technically pull in a DOAS and control it. So a 24-volt interface, if you're wondering where this comes into play, this more comes into play if you have an owner that's specifically requesting, let's say, an Ecobee thermostat or a Nest thermostat or some other third-party thermostat that they just have to have because it's pretty, whatever. We do have a 24-volt interface, so they can have the thermostat that they want. So the DX interface, this is something that's coming to light more and more. I see this. So this is what I consider the non-traditional application of VRF. And traditional being all the fan coils that VRF has to offer. Non-traditional being when you're using a cluster of VRF condensing units to serve an evaporator coil and, let's say, an air handling unit, so a central station air handling unit, and you want to utilize VRF, VRF technology for an indoor air handler up to 32 tons or up to 16 tons. Now, if you're wondering why there's a difference here, okay, it all comes down to the control. If you're strictly looking for return air control, and we all know what systems run well off of return air and which ones don't, okay? Return air control, you're typically looking at large common spaces. That's where that control comes into play better, all right? While looking for 0 to 10 volt control is more where you'd be getting into VAV systems, where you're more controlling your systems off of supply air temp, okay? You just need to remember that right now, as of today, we're limited to 16 tons if you were doing a VAV system, and 32 tons if you're more of a typical constant volume, staged air volume type system. This just goes a little deeper into our DX interfaces. Right here, you can see this is our PMV kit. Basically, our solenoid valves are housed in this box. We have our piping going in and out of the box. Obviously, you see it going to a traditional air handler here. And you can just see what components are needed for the non-traditional approach of VRF. With something like this, guys, we have to get into the weeds, unfortunately, on this type of application. We're going to start seeing it more and more. So just be prepared, to understand your application, because there's definitely going to need to be some questions answered. So there's some more details on our central control, color touch screen. You can do your scheduling, you can see alarms, touches again on the web browser monitoring and control, how many users you can have, and you can see our maximum is 512 indoor units. Personally, I've never seen this many off of one touch screen, but just to note, really the main takeaway on that is you're only going to need one touch screen for your VRF application. So here's really just a dumbed down version of our color touch screen, more push button, non-color. But if you're looking to save a buck and you need some form of supervisory control or central station control of your VRF system, this might be the way to go. Our BACnet interface. If you're working on or if you're looking to install a VRF system where there's an existing lawn work system, we do have a lawn interface. Don't see these much, but we do have it available. So we do have direct iView interface, and if I'm sure you guys are aware of this, Carrier does have their own control system, the iView. The VRF does integrate seamlessly into Carrier iView. So just some of our drivers, what makes Toshiba-Carrier unique. We touched on this, the single phase heat recovery, and guys, it is heat recovery only. It's not heat pump for single phase, and that's with our 6 and 12 ton rotary compressor, which is unique to Toshiba-Carrier, a very robust compressor technology that's been around forever, even before scroll technology. Tried, proven, that's what we have. Pmv refrigerant balance control, we went over that. Minimum capacities per system. No refrigerant bypass. Heat ratings to -13. You know, I'd like to talk about this for a second here, guys. So I can provide you ratings down to -13. And I know it seems like it's just been a race to the bottom on this, on who can go the lowest. I can provide you ratings to -13. But I can also tell you that our units will not shut off below -13. You know, I can't give you, you know, a value on the temperature, but I can tell you that our units will not shut off. And that's due to, as long as our oil monitoring system is operating sustainably, those units will continue to run. We'll continue to derate just like anyone else, but they'll continue to run. Our units will not shut off. Which goes to the next point, no low ambient shutdown or cutout. Isolated compressor section, snow baffles, compressor modulation, 0.1 hertz increments. This goes to show how tight of control is on our inverter compressors. Onto the indoor units. This is particular to the single port flow selector, in that you don't need to necessarily run a dedicated electrical feed to that single port flow selector. So if you think about it, you can piggyback the power that flow selector is going to need off of its respective fan coil. Also with the single port flow selectors, which is important, and it's a nice feature in that they're completely 100% sealed, so no worry on condensate there. They do not have a condensate line. While the larger flow selectors, that being 4 and 6 port, do require a condensate line. So this is more particular, this next line here is more particular to our 4-way cassettes, in that we have full access to serviceable components, or components that need service, through that return air grill. So that grill essentially swings down and you'll have access to everything you need there. The fan, the unit controls, you name it. Medium static units are supplied with 1-inch filter racks. A lot of times you'll see these ducted units not having a filter rack at all. We do have one. And then also just touching on the controls here with our direct iView integration, as mentioned before. Any questions from the audience?
Yes. The question is, what is the benefit of return air control versus supply air control?
Well, really with the return air control, you're not having to mount a wall sensor, or wall controller is what we call, or stat. So it's just one less component there. I mean, that'd be the benefit in my eyes, I guess, and we could set it up either way, right? We can put a stat on the wall for peace of mind if you want to give the occupant some form of control or perceived control. we can do that. I mean, there's a lot of times where we'll put a wall controller in there, and the building engineer may not want the occupant to be able to control it, and just set it up as return air temp.
Yeah.
But really, it's more just the savings on the wall controller.
Yeah, and he asked return versus supply. I don't know, Chun, if you meant return versus space air control, space temperature control, and you worded it wrong, or if you thought there was a choice to control discharge air. But the way Kevin's explaining it makes more sense. It's either a return air sensor or it's a wall sensor that you can adjust. It has to be one of those two. You can't just control it on supply air alone and let it roll. We did have another question from Tula. Is there any low OAT limit for the outdoor unit to provide DX cooling in a cold climate?
Okay. With that one, we're limited to about 25 degrees as far as cooling goes, and really, that is application specific. So me just saying 25 degrees, I don't want you to go take that and run with it. I really want to know what else we're talking about, because we're not just talking about that single zone that's going to need low ambient cooling. When we're dealing with VRF, we're going to have a much larger system. So I might very well tell you to isolate that single zone with, let's say, a ductless system, 1-to-1. That would probably be the best option, but I do understand that there are situations to where you want that cooling and heating to be all on one system. But yeah, more application specific there. Any other questions, Ryan?
Nope, we are all caught up.
And if we, if excuse me, if you guys have any other questions at all, I'm sure that you have assigned TMs or territory managers. You can run anything that you need in regards to VRF through them, and they'll directly reach out to me, and I'll be able to take care of you.
Well, if nobody else is typing any more in, I guess we'll just give it a minute and see what else comes up. But
yeah, I finished a little bit earlier than what I thought, Ryan.
A lot earlier.
Yeah.
All right, well, nobody else is typing anything in, so we thank you guys for your time. We did record this, so I'll get that posted up this afternoon on our website. If you got a coworker that wants to check it out or you want to come back to it again in a month or two, you can. And Kevin, we thank you for your time, man.
All right, thank you guys. Have a good day.